I'm Matt Zerby.
I'm Daniel Basari.
I'm David Leisring.
And I'm Frankie Bauer.
And today we'll be discussing the physics of a bouncy ball, specifically kinetic energy, gravitational potential energy, and forces, and how they relate to Newton's three laws. In our test, we're going to drop these two bouncy balls that are made of the same material. They have different masses, and we're going to drop them from 1 meter off the ground.
At the very highest point where you're going to drop the balls will only have gravitational potential energy. Gravitational potential energy is the energy a ball has, is the stored energy the ball has because of its location relative to the 0 point, which in this case would be the floor. Gravitational potential energy of the two balls is different. This ball has more GPE versus this ball because of the masses. They each have the same height, so that's the same, and they each have the same constant, that is force that is pulling them down, which is little g. Little g is equal to 9.8 meters per second squared. So the only difference between these two balls in the gravitational potential energy equation, which is mass times little g times height, would be the masses. Therefore, so dropping them from this point, this ball, which is more massive, will have a greater force on the earth when it hits the ground. So right here, the gravitational potential energy is there's no kinetic energy at all at this point, because kinetic energy is only the energy an object has because of its motion. And right here, there's no motion. However, at the very bottom, it will only have kinetic energy. It is expected that this ball, one bounce with this one, will bounce back up higher due to simply the mass on this. At the very beginning, their potential energy, this ball has a higher potential energy, even though, because the equation for potential energy is mass times little g, which is 9.8 meters per second squared, the constant force of gravity, as well as the height. They have the same height, and they have little g is acting on both, so the only difference is the mass. Therefore, that we expect that this ball, when bounced with this one, will bounce up higher just because of the math. So right here is all gravitational potential energy. But as the two balls go down, the gravitational potential energy will then transform and change into kinetic energy. So this is the highest point of potential energy, and at the very bottom, right before it hits the ground, it'll have the most kinetic energy as the ball is completely in motion.
Making sure the balls are equal here, we'll drop them at the same height. There we see Newton's second and third law of motion come into play. We did the math here, and we know that Newton's second law is force equals mass times acceleration. We know that acceleration is 9.8 meters per second squared. That's the force due to gravity. And the force came out to be for the small ball 0.05886 newtons. The force of the bigger ball came out to be 0.13734 newtons. When the two balls hit the ground with that force, Newton's third law of motion came into play. So those balls would act on the ground with their respective forces, and the ground would push up back on the balls, which is an opposite and equal reaction in the opposite amount of that force.
Alright, as you guys saw in the dropping the balls, we can tell that it's an open system because if it were closed, the two balls would have bounced back to the original positions up here, but they only bounced up to here, the more massive ball a little higher than the less massive ball. So we can tell that some energy was lost due to air resistance or friction to the ground, and possibly other reasons, but we know some was lost just by telling it did not bounce all the way to its original spot.
So we hope you learned a lot in this video. Just to recap, we talked about kinetic energy, potential energy, and two of Newton's main laws of motion, his second law, which is force equals mass times acceleration, and his third law, which states that for every action there is an equal and opposite reaction. And we also talked about whether this system was open or closed.